Good morning, my little poppets, and welcome to another week of home learning with Miss Pitt. Woohoo! So, what I'd like you to do on your student worksheets is complete the retrieval quiz if you haven't already done so. So, open up the student worksheet that you've been assigned for this lesson and add in your answers to the table. Unpause the lesson video when you're ready to green pen and get your answers. This shouldn't take you longer than 7 minutes. Okay, so the type of substance made from one type of atom is an element. Some of you might have said a pure substance. Water is an example of a compound. A formulation is a mixture that has been measured very carefully in specific quantities. An example of an element is any from the periodic table. So, for example, helium, hydrogen, lithium, beryllium, boron, carbon, nitrogen. No, let's not start that. The formula used for carbon dioxide gas is CO2. Be careful where you are putting the 2. Okay, it is not a big 2. It is not 2 squared. It is a 2 at the bottom. How many elements or compounds are in a pure substance? Just the 1. Squeaky pop is heard if you put a lit splint into a sample of hydrogen gas. A base and an alkali can neutralise an acid. Chlorine gas is tested using blue litmus paper, and a compound is different to a mixture because a compound is chemically bonded, whereas a mixture is not. Please put your score out of 10 on your student worksheet for your retrieval quiz. So we're continuing with our topic of chemical analysis. So looking at what components make up certain substances. Today we are looking at chromatography. So chromatography, not chromatography. So chromatography, you need to be able to use chromatography to determine the purity of a substance. Now in brackets it says RP because it's a required practical. You need to be able to describe how to carry that practical out. You need to be able to describe the method for it, this health and safety aspects, the equipment needed. Now obviously that would be ideal if we were in a lab and we could do that. However, we are going to have to do our best learning virtually through a screen with that one. So I've included another learning intention is to understand how chromatography is used in chemical analysis. Keywords, just the new one today is chromatography, a technique used to separate soluble substances. Soluble meaning that they can dissolve. Now remember, if something's pure, it's made out of one kind of element or compound, and if something is a mixture, it's a substance that's made of elements and or compounds that are not chemically bonded. So what do the following have in common? What do the following objects have in common? They all contain pigments. They all contain some form of chemical dye, some kind of chemical colouring. Now, chromatography. Chroma means colour. To graph. So let's break the word down. Chroma, colour, to graph. Graph is a diagram that gives us information. So basically this provides us with a coloured graph. So chromatography is a technique used to separate soluble mixtures, and this is our result we get once we've separated a soluble substance. Okay, we get a chromatogram, which is a type of graph that shows us the substances separated in a dye, a soluble dye. So chromatography is a technique used to separate soluble mixtures. And you should remember completing chromatography at Key Stage 3. I think you should have done it with black pens, and you should have realised that actually the black ink is a mixture of different components. It's not just one pigment, it's not just one dye, one colour. Okay, so there's lots of applications for the use of chromatography. A big use is the use of chromatography in forensics. Um, so chromatography is involved in fingerprinting. It can be actually used to find out what components are inside of a lipstick. And if this cup was left at a crime scene, they would complete chromatography on the lipstick to find out what components are in it, where that lipstick might have been bought, purchased from, and what brand of lipstick it is, which could potentially follow them to a witness or the perpetrator. Ooh. So just a little interesting fact, okay? In 1983, the Sunday Times newspaper paid over 500,000 to publish diaries written by Adolf Hitler. However, scientists analysed the inks in the diaries and discovered that the inks were not available during Hitler's life. The diaries were forgeries. So again, that's just another application of chromatography and how it's been used to analyse chemicals, for example, inks in diaries. Okay, so you need to be able to describe how to carry out chromatography. So you need to be able to describe the method. So you use a pencil and ruler to begin with. So firstly, you need a strip of chromatography paper. Once you've got that strip of chromatography paper, you use a pencil to draw what we call a baseline, your start line, roughly 1 centimetre from the bottom. Now you use a pencil because we don't want the pencil dissolving. Pencil is insoluble, therefore it won't dissolve and take part in the reaction because we don't want it to run up the paper. You put small spots of each mixture on the baseline. So small spots of each of your sample along the baseline, and use a pencil to label those samples, okay? Then you need a beaker with a very small amount of water in it. For this experiment, we're using water as our solvent. So that solvent, the water, is going to dissolve each sample, carry it up the paper, and separate out the components. Now it says put the paper in the beaker. A key stage here is when you put the paper in the beaker, the solvent should be below the ink samples. So in the diagram here, you can see we've got our baseline there with our samples on it. We've got our solvent in the beaker, and the solvent is below the samples. If the solvent was above the sample would wash into the beaker rather than the solvent travelling through the ink and taking it up the paper. The ink would dissolve into the trough of the beaker, the bottom of the beaker. Now, once you've put your chromatography paper in the beaker and the solvent is touching the bottom of the paper, the solvent starts to travel up the paper, it dissolves the samples, and it will carry it up the paper with it. And any components will be separated out based on their solubility. Anything that's less soluble will be lower down on the paper, anything that's more soluble will be higher up. Now, once the solvent's reached the top of the paper, take the chromatography paper out and leave it to dry. Once it's dried, you can use a pencil line to mark out where the solvent reached, the top of the solvent line. Now, we call that the solvent front. Okay, so just to talk you through it, ignore that chromatography in the middle there. That should have been animated and zooming in. I do apologise. So you've got your chromatography paper. You need a baseline drawn in pencil 1 centimetre from the bottom. You add on your samples. It's important that they're spread apart so when they are being dissolved, they don't run into each other. So you add on your samples on your baseline. You then label your samples A, B, C, or X, Y, Z in penso because we don't want the labels dissolving. You then get a beaker with a small amount of water, a shallow amount of water in the bottom. You place your chromatography paper in it. Now the solvent will begin to absorb up through the paper. As the solvent absorbs, it will travel through the paper, dissolve in the dyes and carrying up the paper with it. Now, there's two phases in chromatography, the stationary phase and the mobile phase. Stationary means still. So the stationary phase is the paper. The mobile phase, mobile means mobile, to move, is the solvent because the solvent moves through the paper. So stationary is the paper, it doesn't move. The mobile phase is the solvent because it travels through the paper, dissolves the samples, and carries them up the paper with them. Now, you would have, in school, we would use a splint with a paper clip to support the paper in the beaker, and you should get a result of something that looks like this, and we call the final result the chromatogram. So task 1, click the link and watch the video. So on your student worksheet, you've been provided with this link. Please click it, watch it. I'm not embedding the video into my lesson video because the quality tends to be quite poor. Pause this lesson video, come back once you've done that. Okay, moving on. So task 2. What I would like you to do for this, because chromatography is a required practical, I'd like you to complete the following tasks. So write a list of equipment, list any hazards, risks, and how to reduce them. Write a clear method. Now remember, a method should be clear, broken down into clear steps, so either bullet points or numbers. And then number 4, identify the 2 stages. Number 5, why is the baseline drawn in penso? Number 6, explain why it's important for the samples to be above the solvent and not below. And then there is a challenge. If a sample is insoluble during chromatography, what could you change so that it is soluble? Pause this lesson video, go and complete these questions on your worksheet, come back once you've done that. Okay, so green pen as follows. So the list of equipment, the answers in red are optional, you don't have to include them. The hazards were, a hazard is the ink, the risk is it could go in your eye, to reduce it you should wear goggles. Another hazard was the glassware, the risk is that it could break and cut your skin. To reduce that, you should handle it carefully, don't leave it on the edge of a table, yada yada. Number 3, so remember guys, your method should be clearly laid out in bullet points or numbered stages, and you should begin with drawing a baseline in penso, you add your samples, you then get a beaker with a small amount of water, you place your chromatography paper in it, ensuring the samples are above the waterline, wait for the solvent to reach the top, take out the paper and mark the solvent line. Okay, so the stationary phase was the paper, the mobile phase was the solvent, the baseline is in penso because it is insoluble so it won't dissolve. You need to have the samples above the solvent so the solvent runs through the sample, also the spots don't wash into the solvent. Now, if something is insoluble, well, you could change the solvent. So, for example, you could change the water to an acid or an alcohol. So there's 2 ways to interpret a chromatogram. There's 2 ways to analyse it to find out what components are inside of the substance. So you can compare it to a known chromatogram, a known sample. So for example, you can see here, you've got sample X and you've got A, B, C and D. Well, does sample X contain pigment A, B, C or D? Well, we compare it to the chromatogram, we look over, is there any that match it? Yes, D matches it. So X contains pigment D. Or, secondly, you can work out what we call the RF value, the retention factor of a component, of a substance. Okay, and the RF value is just the ratio between the distance travelled by the sample divided by the distance travelled by the solvent. So reading a chromatogram. So let's look at questions in terms of comparing it to a known sample. So here we can see that brown ink has got 1, 2, 3 different dyes in it, 3 different substances. It's not pure. We can see red, blue and yellow all have one dot, one dye. So we can see that red, blue and yellow are pure substances because they only contain one component. Whereas we can see brown ink is a mixture of 3 different components. So actually brown is a mixture of red, is a mixture of yellow, and is a mixture of blue. Now we've looked at this picture already, we can see that X corresponds to D, they're both the same, so X must contain the pigment, which is D. And if we looked at another chromatogram, a question might be, which number sample is pure? Well, we can see that number 4 has only got one component, one sample, one dot. Okay, so we can see that it's pure. It might say which substance has got 4 components in it. Where we can see that 1 has got 1, 2, 3, 4 dots. 3 has got 1, 2, 3, 4. So 1 and 3. Okay, so let's look at an example question. So which horses, so we've got a chromatogram here. We've got a table, a key to show us what the samples are along the bottom. So sample 1 is the result for caffeine. Sample 2 shows the result for paracetamol. And then 3 to 6 shows the urine sample of different horses. So which horse, if any, have been given caffeine? So if I look on the table, caffeine is spot 1. So let's look on the graph. Spot 1, okay, has got a spot or a dot between 7 and 8. Now, if I look across the chromatogram, I can see there's no other dots that match up to the caffeine. So none of the horses were given caffeine. Which horse, if any, have been given paracetamol? So in the table, you can see that the sample is sample 2 for paracetamol. Let's find sample 2 on the chromatogram. There's the result for the paracetamol. Let's look across at the chromatogram, the results for the horses, and you can see that we've got a matching sample in 5. So we know that horse 5 has been given paracetamol. What I'd like you to do is pause the video, go and complete this task on your student worksheet. There are 5 questions relating to this chromatogram here. This diagram is on your worksheet as well. Pause the video, come back once you are done. Okay, so let's go through the answers. Green pens. Which sample contains pure dye? Must have been A and D because there's only one dot for each one of those. In sample X, there are 3 different dyes. B and C are samples that contain 2 different dyes because they've got 2 different dots as their results. The most soluble, remember the most soluble substances travel higher, so it should have been purple. The least soluble travel the least on the paper, so that would have been blue. So the second way of analysing a chromatogram is calculating what we call the RF value, the retention factor. Now, every single substance has got a known RF value. And that RF value can be found in a shared index, in a shared database that scientists can all access. So the RF value is the ratio between the distance moved by the substance, by the dye, divided by the distance travelled by the solvent. So remember, distance travelled by the solute, remember the solute being the dye, the sample, divided by the distance travelled by the solvent. So if we looked at this chromatogram here of this yellow dye, we'd use a ruler to find the distance travelled by the solute, by the dye, by the ink, by the sample. So many words for one thing. Wow. So if we use the ruler, we could see that the dye travelled 3 centimetres. We then need to find out the distance travelled by the solvent in total. So again, we'd use our ruler, we measure in centimetres, and we can see it's travelled 6. So to work out the RF value of this substance, we'd do 3 divided by 6 gives us a result of 0.5. Now, RF values are never above 1, so if you've got an answer above 1, you've done it the wrong way around. So what I'd like you to do is go back to your student worksheets, complete this task. You are entitled to a calculator, so use your calculators, work out the RF value for each colour in the diagram, unpause the video when you're ready for your answers. Okay, so red's travelled 2 centimetres. The solvent's travelled 10, so it should have been 2 divided by 10, gives you 0.2. Purple and blue are as follows. And what we could do is with those results, we could compare them to known RF values and work out what components they are. So that leads us on to our consolidation questions. There are 3 consolidation questions. These diagrams are in your student worksheet. Pause the video to complete the questions, unpause it when you're ready for your answers. So the answers are as follows. The 2 mistakes the student made was the start line was drawn in ink. Now it asks you to identify and describe the problem. So the identifying the problem is that the start line's drawn in ink, that's 1 mark. So the line would run up the paper, that's the 2nd mark. The second problem you needed to identify was the start line below solvent level. So you can see that the samples and start line are below the solvent, or the solvent should be below the samples, and that would cause the samples to dissolve into the solvent rather than the solvent travelling through the solutes. Number 2, which of the inks is most soluble and why? Well, we can see that yellow's travelled the furthest up the paper. So yellow gives you 1 mark, so you've identified it and you've said why, because it travels furthest up the paper. That gets you your 2nd mark. And then finally, to calculate the RF value, you needed to do 13 divided by 44. Should have given you on your calculator 0.294. That gets you 1 mark, and then because it asked you to give your answer to 2 significant figures, your final mark comes from rounding to 2 significant figures. So, red, amber, or green, I would like you to rate the learning intention for today. There is a small section on your student worksheet to do this. Once you've rated your learning intentions, please submit your work and send it back. Thank you for accessing your work and taking the time to complete home learning year 11, and I look forward to seeing your returned work. Thank you guys, and I will see you, well, I probably won't see you later, but I will speak to you soon.